Here at the Victor Chang Cardiac Research Institute, we've shown for the first time that a genetic risk factor can interact with an environmental insult to cause a very common birth defect called congenital scoliosis. And we often think about this more in terms of nature and nurture. This finding is actually generally applicable because it's not just going to be relevant to vertebral defects, but we also think it's very likely that it might explain the causes of many sporadic defects that involve the heart, the kidney, the cranio-facial development, and also limbs. And we've shown that interaction between a genetic predisposition and low oxygen or hypoxia can in fact increase the likelihood of a baby developing vertebral defects by 10 times. For the vast majority of birth defects, the causes are unknown. And so in the first instance, our findings allow genetic diagnosis of particular types of birth defects. And this is very important for families to know why their child has been born with a defect. We can also use this research information to advise women who are thinking of getting pregnant, or indeed who are pregnant, about the types of activities and factors that they need to avoid during that pregnancy. For those women who have birth defects in their family, they need to be extra mindful of the sorts of environmental factors that can impact on the development of their babies. Many of us, however, don't know about our genetic risk factors with respect to having babies with birth defects, so we too need to be very mindful of environmental factors that could cause birth defects. We've shown that mutation in 2 genes can cause vertebral defects or congenital scoliosis. But interestingly, not everyone who inherits the mutation actually develops the vertebral defect. So for example, you could have a grandfather with a vertebral defect and a grandson with a vertebral defect, but it skips a generation in between. And this sporadic nature of inheritance can be explained by a second factor, which is the environmental impact on the genetic risk factor. So hypoxia interacting, for example, with the gene mutation. Because we've identified the pathway that interacts between the genetic predisposition and the environmental factor that causes congenital scoliosis, we know that that pathway is also very important for the development of the heart in a baby. And therefore, we think that this gene-environment interaction may actually explain the causes of many cases of heart defects in babies. Congenital heart disease is the most common form of birth defect, occurring in about 1 in 100 babies. And so our research now is focused on trying to understand the causes of a vast majority of heart defects in babies.